Hi, today's lesson, we're gonna learn how to do partial fraction decomposition. Okay, so what is partial fraction decomposition? Let me give you an example just to see what it means. So usually what you are given, for example, 3 over x minus 1 plus 4 over x minus 2, and you are supposed to combine these two fractions together, right? So what do is we find the common denominator and then we add them, right? So the common denominator is x minus 1, x minus 2. So the first fraction missing x minus 2, x minus 2. And the second fraction missing x minus 1, x minus 1. Okay. Put the parenthesis here. All right, and now we have the common denominator. So this is equal to, the common denominator is x minus 1, x minus 2, and you add the top, right? So if you combine like term, I have 3x plus 4x is 7x, and I have negative 6 plus negative 4, it's negative 10. Okay, so this is what we usually do, right? We combine fractions together. Now, partial fraction decomposition is the reverse process. So usually you are given this, and then you are asked to decompose them. You break them apart into fraction. It could be 2 fraction, 3 fraction, depending on how many linear factors do you have in the denominator. Okay, so let me give you an example. Oh, by the way, we are going to we are going to go through 4 cases. So we have distinct linear factors. We have repeated linear factor, irreducible quadratic factor, or prime quadratics, right? Quadratic expression that you cannot factors, and last, improper partial fraction, where you have the degree of the numerator is larger than the degree of the denominator, right? Okay, so case 1 is distinct linear factors. So the denominator is a product of distinct linear factors. Right? So for example, I have ax plus 2 over x squared minus 1, right? So this is quadratic, but I can factor into the linear factors, right? So if I factor this, I have x plus 1 and x minus 1. So if I would decompose this original fraction, I would decompose it into 2 fractions, something over x plus 1 and something over x minus 1. How do I know that it's 2 fractions? Because I have 2 linear factors, right? I have 2 linear factors, x plus 1, x minus 1, right? Now, remember that the degree of the numerator is always 1 less than the degree of the denominator. Okay, so because I don't know what the numerator would be, I'm going to call this one a and this one b. Okay, so, or is a x to the 0, right? In the denominator we have x to the first, so the degree of the numerator is always 1 less than the degree of the denominator. Okay, all right. Okay, so all right, now we're going to find the common denominator of this equation, right? And we know that it's going to be x plus 1, x minus 1, right? So what we're going to do is we're going to times both sides. We're going to times both sides by x plus 1, x minus 1 over 1. And then you distribute that common denominator into each of the fractions. Okay, so if I distribute that to the left-hand side, it's gonna cancel, right? So what's left is just ax plus 2, right? And if I distribute into a over x plus 1, x plus 1, x plus 1 cancel. So I have a times x minus 1. And for the second fraction, it would be times x plus 1, because x minus 1 cancel. Okay. All right. So ax plus 2 on the left-hand side, I'm just rewriting that. On the right-hand side, I'm gonna distribute the a term and the b term. Okay, so we ax minus a plus bx plus b. Okay. All right. Rewrite the left-hand side. On the right-hand side, I'm gonna combine like term and factor out the x. So I see I see this and this, right? I have a common factor, which is x. So I'm going to factor out x. And what's left? A plus b, right? And then I see this and this. And then so plus minus a plus b. Okay, that's my constant term. Right. Okay, this is the equation, right? I have ax plus 2 equal the right-hand side, right? So this is the equation. Because it's an equation, therefore, the ax term on the left-hand side, so maybe I'll do this. So this term right here needs to be equal to this term, right? And then also this term right here needs to be equal to this term, right? So ax needs to be equal to a plus b times x, right? So that mean this imply a plus b must be equal to a, right? The coefficient of the x terms need to be equal to each other, right? And then the constant will be equal to 2, so be negative a plus b need to be equal to 2. Okay, and then you're going to solve for a and b, and then you're done. Okay. I'm going to solve it using elimination method. So I'm just going to add the two equations. Right, so if I add, the a term's gone. So this 0. I have 2b equal 10, imply b equal 5. Right, now I have b, I can solve for a, right? You can plug it back in here. Okay. So this implies a equal a minus 5 is 3. Okay, so I got a equal 3 and b equal 5. Right. Okay, so rewrite the partial fraction decomposition. So that means your final answer is so let me rewrite the whole thing here. So ax plus 2 over x squared minus 1. I'm going to decompose it into what, 3 over x plus 1 plus 5 over x minus 1. That will be our final answer. Okay. All right. Repeated linear factors. Repeated linear factors. The denominator is a product of linear factors, some of which are repeated. Right. So for example, I have 4x squared minus 1 over x times the quantity of x plus 1 squared. Why it's linear? It's linear because if you look at the denominator, all the factors are the degree of 1. Okay, but then if you notice that the second factor is x plus 1 is being repeated, is x plus 1 and then x plus times x plus 1, right? It have a second degree. So it's repeated because it has second degree, third degree, fourth degree, etc. All right. Okay, so this, if I would decompose this, is going to be equal to a over x plus b over x plus 1 plus c over x plus 1 squared. Okay, so the common denominator here, LCD, the least common denominator is x times x plus 1 squared, right? So we cover all the bases. Now, in the beginning, I told you that the degree of the numerator is always 1 less than the degree of the denominator. But then you say like, hey, Mimi, this one doesn't look like it, right? The bottom have the degree of 2 and the top is 0 because x is 0 is constant. Now we only look at the quantity inside the parenthesis. Okay, so because this guy is still at a first degree, so it's still linear, right? And up here we have x is 0, so we good. Okay. All right, so we do the same thing that we did before, LCD, right? So we're gonna multiply both top and bottom. I'm sorry, multiply both side by the LCD. So multiply by x times x plus 1 squared, maybe equal 1. I like to do that. It's a good habit. Okay, so distribute that into each of the fractions. So if I distribute into the left-hand side, everything cancel. Okay, so just 4x squared minus 1 for the left-hand side. On the right-hand side, if I distribute to the eighth terms, I have the x cancel. I got a times x plus 1 quantity square, right? Plus b x times x plus 1. One of the x plus 1 cancel. And last cx. Okay. All right. Rewrite the left-hand side. On the right-hand side, I'm going to distribute it out and rearrange. Okay, so a times, if I would expand x plus 1 squared, it's going to be x squared plus 2x plus 1 plus b x times x plus 1 plus cx. Just leave it like that for now. And then we're gonna do it all at once. So I have ax squared plus 2ax plus 2a plus a plus a. Sorry, plus a plus bx squared plus bx plus cx. Now combine like term. Right. I see ax squared, bx squared there, right? So I have a plus b, all of that times x squared. And the x term, I see that, this, and this, right? So I have plus 2a plus b plus c, all of that times x. And then the constant term, the constant term, which is just a. So plus a. Okay, and then bring down the left-hand side, 4x squared minus 1. Okay, and this same argument like we did before, the coefficient of each of the term need to be equal to one another. So this imply a plus b is equal to 4. Now, on the left-hand side, you say that I don't have the x term. Well, so we can put a placeholder there, right? So this one, if I rewrite this, maybe maybe look a little, maybe I'm gonna make a little space here. If I rewrite this, I'm gonna add a little placeholder there, plus 0x. Okay, so the constant of the x term will be 0 on the left-hand side, right? So 2a plus b plus c equals 0. And then the constant is a equal -1. Right, so we have one down, 2 more to go. So a equal -1. If I plug into the first equation, if I plug into this equation, I can solve for b. So this is b equal to 5, right? B equal to 5. Yeah. Well, I have a, I have b. Now I can plug into the second equation to get c, right? So this implies 2, let me do it slowly so I don't make a mistake. 2 times -1 plus 5 plus c equals 0. So c equal -2 plus 5 is 3. So c equal -3. Okay. So we have a, b, and c. All right, now I'm going to rewrite the whole thing. So I have 4x squared minus 1 over x times x plus 1 squared is equal to, we have 3 fractions, so -1 over x plus 5 over x plus 1 and plus -3 over x plus 1 squared. That'll be our final answer.